Good afternoon. We are here to show how to solve a one-step equation with fractions, but with also the purpose of showing how to do the work in an organized way. Too often, it's hard to make sense of what is written down, even though a student is clearly attempting to solve an equation. This is a demo to try and show it in an organized fashion. So let's see. We have an equation here. Excuse me, guys. Negative 2 and 2/3 plus k equals 1 1/2. One first step I could take is to convert everything to an improper fraction, and that would have less written on the page, which is sometimes nice to as a way to clean up. So 3 times 2 is 6, plus 2 is 8. So this changes to 8/3 plus k equals, we'll do the same thing to this side, 2 times 1 is 2, plus 1 is 3 halves. So already it looks a little less cluttered than the first step. Now, what is happening to the k? Well, it looks like I'm adding a negative 8/3. Just as a way to rewrite the problem to think about it differently, with adding, you know that 2 plus 3 is the same thing as 3 plus 2. So I can change the order of this just to see what it looks like. If I do that, I have k plus negative 8/3 equals 3 halves. Well, plus a negative is the same thing as writing k minus 8/3. So I want to get the variable by itself. That's what solving includes, is isolating the variable. Here, since I'm adding a negative 8/3, I need the opposite of negative 8/3. The opposite of negative 8/3 is 8/3. Now, if I'm going to add 8/3 to this side, I must also add 8/3 to this side. That is part of our principle here. We want to show the work on both sides of an equation. Not just write it on one side, but actually show it happening to both. And you can see when we rewrote it, we'd get the same step. If I want to undo subtracting 8/3, I would add 8/3. And again, I would show it on both sides of the equation. From here on out, let's just work with this particular equation that we set up. So, on the left side of the equal sign, we have these opposites, and when you add opposites, it becomes 0. So the only thing left on the left side is k. On the right side, we have 3 halves plus 8/3. Now we have to use our rules for adding fractions with different denominators by making the denominators the same. So in this case, I want to make both of these have a denominator 6. To do so, I'll multiply this by 3. And if I multiply the bottom by 3, the denominator, I have to multiply the numerator by 3. For the second fraction, I have to multiply the numerator and denominator both by 2. When I do that, now I see that k is equal to 3 times 3 is 9, 2 times 3 is 6, plus 16/6. Well, we like that because we're adding the same thing, in this case 6. So this is the same thing as 9 plus 16/6. So k is equal to 25/6, which is also, as a mixed number, we could divide 25 by 6, and we have 4 1/6. Personally, I like leaving things as an improper fraction. The question is this the correct solution? Well, we won't know until we check. So let's check. We're going to replace our variable k with 25/6. And I'm going to use original equation, so negative 2/3 plus our value for k, 25/6. Does that equal, I'm asking the question, does that equal 1 1/2? Let's change everything to improper fraction, which we've done before already, so we know that the first fraction here is equal to negative 8/3 plus 25/6. Does that equal 3 halves. Well, what we need to do now is simplify this left side and find out, is negative 8 thirds plus 25/6 equal to 3 halves? To do that, we have to make this to have the same denominator, and we'll do that by multiplying top and bottom by 2, which I'll write in red here. So now we have negative 16/6 plus 25/6. Again, I'm asking, does that equal 3 halves? So we have negative 16 plus 25 all over 6. Negative 16 plus 25 is 9. So I have 9/6. Is 9/6 the same thing as 3 halves? Well, we can rewrite 9/6 as 3 times 3. And we can rewrite 6 as 3 times 2. And we see we have a 3 at top and bottom. So let's cancel those out. And sure enough, 3 halves equals 3 halves. That checks. That means that our solution that we found here, k equals 25/6, is correct. We're done. And aren't we glad for that?